In this video, I will teach you about the chain rule. The chain rule allows you to take the derivative of a composite function. Basically, to take the derivative of a composite function, first you take the derivative of the outer function, leaving the inner function unchanged. Then you multiply by the derivative of the inner function. To demonstrate, let me first colorize this function for you. So we have the outer function, which is y equals parentheses cubed. That's the outer function. And then we have the inner function, which is the x squared plus 1. Now, focus on the outer function by itself for a minute. According to the chain rule, first we take the derivative of the outer function. Now, imagine that this function was y equals u to the third power. How would we take the derivative of this? We would use the power rule, right? So we would take the 3 and we'd put it in the front, and we'd have 3u, and we'd reduce the power by 1, so we'd have 3u squared. So we're going to do the same thing with the outer function. Basically, treat the parentheses like a variable. So y prime would be, and I'm going to take the 3 and put it in front, and then I will reduce the power by 1. So I've taken the derivative of the outer function. For now, we will leave the inner function alone. So the inner function was the x squared plus 1. And at this step in the derivative, we leave the inner function the same. But now we're going to multiply by the derivative of the inner function. So we're going to multiply by the derivative of this. The derivative of 2x is, the derivative of x squared is 2x, all right? That's just the power rule. The derivative of 1 is 0, so we don't need to write anything. So basically, this is the answer. This is the derivative. We could reorganize it a little bit and multiply the 3 times the 2x. So we could write y prime is equal to 6x times x squared plus 1 squared. And that would be the final answer. For example 2, let's find the derivative of f of x equals the quantity 3x minus 2x squared to the third power. So we have an inner function and an outer function. Let me colorize this for you. So the outer function is the parentheses to the third power part. And the inner function is the 3x minus 2x squared part. So, according to the chain rule, if we want to find the derivative of a composite function, we first take the derivative of the outer function, leaving the inner function the same. So the derivative of the outer function, according to the power rule, the 3 will come to the front, and we reduce the power by 1. So now we've taken the derivative of the outer function. We leave the inner function the same at this stage. But then we multiply by the derivative of the inner function. The derivative of 3x is just 3. And the derivative of 2x squared, we're going to use the power rule and do 2 times 2, so that'll make 4. We have to reduce the power by 1, so it'll just be x. And that's it. It's just that easy. Before we do example 3, I need to do a brief review on the relationship between radicals and fractional exponents. So remember, imagine that we have u to the p over r power. When you have a fractional exponent, the numerator and denominator are in the form power over root. That's why I'm using p and r, because p stands for power and the r stands for root. So this would be the same thing as having u under a radical, and r is the root, so that would go right here. P is the power, so that's going to go right here. Now, understand that this is a two-way street. So imagine that I gave you the cube root of u squared. This would be the same thing as a fractional exponent, u to the 2/3 power, because the fractional exponent is in the form power over root. And you see we have cube root and the power is 2. So power over root becomes 2/3. Now notice that that's just what we have for this problem right here. 2 is the power and 3 is the root. So we could rewrite the function f of x using a fractional power. So we will have the 2/3 power. This is the outer function. The inner function, of course, is the x squared minus 1 part. So in this form, we are ready to do the chain rule. The chain rule says that if we want to find the derivative of this composite function, we need to start by taking the derivative of the outer function. So we're just going to do the power rule. The exponent is going to come to the front, so we're going to have our 2/3 right here. And then we need to reduce the power by 1. So subtracting 1 would be the same thing as subtracting 3 over 3. So that's going to make negative 1/3. All right, so we've taken the derivative of the outer function. We are to leave the inner function the same. But now we multiply by the derivative of this inner function. The derivative of x squared is 2x. The derivative of negative 1 is 0, so we don't need to write anything else. For this next step, I want you to focus on this part of the function right here. All right, we have something raised to the negative 1/3 power. Let's remember how this works. If I had u to the negative 3 power, for example, that would be 1 over u to the 3rd power. So if I have u to the negative 1/3 power, that's going to be the same thing as 1 over u to the positive 1/3 power. And that's exactly what we have right here. So just focusing on that part for a moment, this is going to be the same thing as 1 over, and we'll have our parentheses to the 1/3 power. So of course, inside those parentheses, we still have our x squared minus 1. Now, what about the 2/3? The 2 is in the numerator and the 3 is in the denominator. So when we multiply 2/3 by what we just wrote, the 2 is going to end up in the numerator and the 3 is going to end up in the denominator. Now, what about the 2x over here? Well, this is like having 2x over 1. So the 2x is going to end up in the numerator. So let's just clean this up a little bit. We're going to have f prime of x is equal to, and in the numerator, we're just going to have 4x. In the denominator, we have this 3. But instead of doing the 1/3 power, let's go back to a root. And the 1/3 power is the same thing as the cube root. The cube root of x squared minus 1. And that's the final answer. Before we do example 4, let me remind you how negative exponents work. Remember that if I have u to the negative 2 power, that would be 1 over u squared. But this is a two-way street. If I gave you 1 over u squared, if you wanted to, you could write this as u to the negative 2 power. If I gave you negative 7 over u squared, this would be the same thing as negative 7 u to the negative 2 power. Now, that's exactly what we have in this function. We have negative 7 over something squared. I'm going to rewrite it as negative 7 times something to the negative 2 power. So your first step will be to write g at t equals negative 7 times parentheses to the negative 2 power. And then that's the outer function. The inner function is the 2t minus 3. So now we are ready to do the chain rule, which says that if I want to find the derivative of this composite function, I will first take the derivative of the outer function, shown here in blue. So I'm going to do the power rule and multiply negative 2 times negative 7, and that's going to make a positive 14. Then I reduce the power by 1. So if I take negative 2 and I subtract 1 from it, then I'm going to have the negative 3 power. At this stage, we leave the inner function the same. But we then multiply by the derivative of the inner function. The derivative of 2x is, well, 2t is simply 2. And the derivative of negative 3 is 0, so we don't write anything else. So this is basically the answer right now. Focus on this part of the function. Because of the negative 3 power, that's going to be the same thing as 1 over parentheses to the third power. And of course, still inside of the parentheses, we have our 2t minus 3. So we just dropped it down to the denominator. In the meantime, we've got the 14, which is like 14 over 1. So that 14 is going to end up in the numerator. And we still have this 2 that has to be multiplied. This is like 2 over 1. So that 2 is going to end up in the numerator as well. So far we have g prime at t is equal to this. So when we write the final answer, the only thing that's going to change is the numerator is going to become 28. And that's it. That's the final answer.